Simple machines like levers take advantage of the fact that the work it takes to move an object equals the force you apply on the object times the distance you want to move it. So if you apply 20 newtons of force on an object to move it 1 meter, you can do the same amount of work by applying 10 newtons of force on the object over 2 meters. So, if you distribute the amount of work you have to do over a longer distance, that means you do not need to apply as much force to do that work. And that's what a lever does. A lever is supported by a fulcrum, which the weight pivots around as you apply a force to it. Notice that the weight travels along the path of a circle centered at the fulcrum. The point where you apply the force to the lever should be further away from the fulcrum than the weight, so that it travels along a bigger circle centered at the fulcrum. So if the hand is twice as far away from the fulcrum as the weight, then it will travel around a circle with twice the circumference, and therefore it will travel twice the distance. Since the hand is traveling twice the distance, it only has to apply half the force it would take to do the work of normally lifting the weight. So if the weight is 20 grams, it would feel like you're lifting only 10 grams. And you can actually rest the 10-gram weight in the position of the hand, and the two weights would be in balance. This same principle is at work when using a wrench to tighten a bolt. The circle the bolt rotates around is much smaller than the one which your hand travels around when you apply the force. Therefore, you're distributing the work of tightening the bolt over a longer distance. And the force you have to apply does not have to be as great as if you tried to tighten the bolt with, say, your fingers.